हरि करना।
Now let's see another distribution, which is chi-square distribution. So the chi-square distribution is a continuous probability distribution that arises in many statistical tests, particularly those involving the analysis of variance, ANOVA, and goodness of fit tests. It's a special case of the gamma distribution, and its probability density function PDF probability density function depends on a parameter known as the degrees of freedom. Degrees of freedom. Okay, so this is how it's indicated. It indexed by degrees of freedom nu. You can say nu. So nu and x it's chi-square 2. It's a chi-square. So this is how we represent this one, the chi-square distribution. So assuming independence x1, x2, and so on xn variables, random variables we have, and I value varies from 1 and so on n, then sigma I is equals to 1 to n xi is similar to the chi-square of different degrees of freedom. And the density function, this is the formula for density function that you can see on the screen. So if you want to use an Excel sheet to basically plot a chi-square distribution, you can simply use this function chi-square dot rt, and you need to mention the x value as well as nu. That's your degrees of freedom. So virtually all statistics textbooks give upper tail cutoff values for commonly used upper and some used and sometimes lower tail probability, but normally you'll have a upper tail probabilities with you. So here you can see various chi-square chi-square continuous probability distribution plots for different degrees of freedom. And degrees of freedom is 4, then it's completely skewed towards right. As the degrees of freedom is increasing from df10, df20, df30, df50, slowly it is taking a proper normal curve kind of shape. And it's becoming slightly it's pretty normal or bell-shaped curve. It's not completely bell-shaped, but it's slightly improving from the skewed to the normal one. So let's see the properties for this. So the properties of chi-square distribution include, it's a right skewed distribution. The chi-square distribution is a right skewed distribution with values ranging from 0 to infinity. From 0 to infinity. The mean of the chi-square distribution is equal to its degrees of freedom. The mean of the chi-square distribution is equal to its degrees of freedom, while the variance is equal to 2 times of the degrees of freedom. So variance is equal to the 2 times of the degrees of freedom. So the sum of the independent and identically distributed normal random variables squared follows a chi-square distribution. So the chi-square distribution is used to test the goodness of fit of a sample to a specified probability distribution, as well as in hypothesis testing for comparing the variances of two populations. So this is what we used to calculate the critical value for chi-square distribution. But for that you need to have two values. You need to have the degrees of freedom uh, significance level. Significance level. So the value, the mean is equals to degree of freedom, and variance is equals to 2 times of mean. And if you have a degrees of freedom 10 and then 0.05, then your critical value is here 3.94. And if your degree of freedom is 50 and then 0.05, it will become 34.764. That's it. That's how we calculate the critical value. So the chi-square distribution is widely used in statistical analysis and is a key tool in fields such as biology, engineering, and the social sciences. So it's an important concept to understand for anyone involved in data analysis and the statistical modeling.